Today's lesson is on Newton's third law. The main idea of the lesson is that forces occur in pairs. The forces within an interaction pair are equal and opposite. Let's look at an example. In this figure, you can see a boy pulling on a toy that his dog is holding on to. The forces of the boy pulling on the toy are equal and opposite to the force that the toy is exerting on the boy. You can see these two vectors, and the forces are pointing in opposite directions. The magnitude is equal. This sort of thing is known as an interaction pair. In your equation sheet, you'll see the forces are done by subscripts. The force, if you have two objects, A and B, then the force of A acting on B is equal and opposite to the force of B acting on A. This is an example of Newton's third law. It states that all forces come in pairs. Two forces in the pair act on different objects. They're equal in strength and opposite in direction. Mathematically, we express this by an equation that you see on your equation sheet. The force of object A acting on B is the negative of the force of B acting on A. So let's look at some examples. We have a case of a ball sitting on a table on Earth. So first off, we see our free body diagram, the way that we had drawn them previously. The ball is sitting on the table, so we have forces acting on the ball. We have the force of gravity, that's the force of the earth acting on the ball. We have the table pushing upward on the ball. Now these forces are not an interaction pair. These are two different forces that are acting on the ball, the object represented by the dot. Let's look at the interaction pairs. The table is pushing up on the ball. The ball is pushing down on the table. This is an example of an interaction pair. These forces are equal and opposite to each other. Now that may seem fairly obvious. Usually for contact forces, this is quite obvious. The one that may not be so obvious is that the force of gravity is the force of Earth pulling down on the ball. The ball pulls back on the Earth with an equal and opposite force. You may think, though, if I were to drop this ball, it would fall toward the Earth. I wouldn't see the Earth move very much. And we'll talk about why that's the case in a moment. So if there were an unbalanced force on the Earth would accelerate. But keep in mind, acceleration is inversely proportional to mass. Because the Earth's mass is so large in comparison to any other object that we'd normally consider, we would neglect the acceleration of the Earth. We will do a series of problems like this. We have two objects colliding that have very different masses, like a bus hitting a bug. The force between the two is equal and opposite. That mean old bug hits the bus just as hard as the bus hits the bug. But because the bug has much smaller mass, it will experience a much greater acceleration. This is a tricky, rather non-intuitive concept, so read this carefully, understand what is going on. Do make sure that when you do free body diagrams, you're only looking at the forces acting on an object. Make sure that you just picked out the forces that are acting on the object. An interaction force acts on two different objects. One more question I want you to consider. How is it that you could kick a soccer ball? If you come up and apply a force, if you kick the ball with your foot, the foot applies a force to the ball applies an equal and opposite force to the foot. So at first you might think, oh, there's equal and opposite forces, there's no net force, nothing's going to happen. But remember, when you do a free body diagram, you only do the forces acting on a single object to see how that object moves. It's going to take some time. We want you to think about these carefully, look it over. So read this section carefully, answer the questions, and the launch homework.